Hi, and welcome to the Learn Kubernetes with Google video series. My name is Chris Fenor, and I'm a technical writer at Google. In this episode, I'll describe two popular Kubernetes network models, the flat mode network model and the island mode network model. This talk is very much based on an excellent webinar that Tim Hawken made in 2020, and a link to Tim's talk appears in the description below. These two network models are very popular, and they differ from each other in some important ways. In this video, I'll briefly compare them and mention some of their advantages and disadvantages. Before we talk about the two models, though, let's go back to first principles for a second and point out that Kubernetes promises to do only two things. First of all, Kubernetes guarantees that all the pods in a cluster can communicate directly with each other without having to resort to something like network address translation, or NAT for short. Even pods that are on different nodes can communicate directly with each other. And the second thing that Kubernetes guarantees is that agents on a node, such as system daemons or kubelets, can communicate with pods on that node. From this very short list, we can see that Kubernetes doesn't guarantee that anything outside a cluster can communicate with the cluster. And so a natural question to ask is, what happens when a network is hosting two clusters as shown in the diagram? How do pods in cluster number 1, for example, communicate with pods in cluster number 2? And how do clients or servers outside the clusters communicate with a pod inside a cluster? This video explains how a flat network model and an island network model answer these questions differently. So in flat networks, pods have unique IP addresses across all the clusters. For example, pod A in cluster number 1 has IP address that you won't see anywhere else in cluster 1 or 2. All the pods have universally unique IP addresses. This means that, assuming no firewalls or other policies which can block traffic, pods from cluster number 1 can directly communicate with any of the pods in cluster number 2. No gateway or translation is required. Similarly, clients and servers outside a cluster can directly communicate with a pod inside a cluster thanks to that pod's unique IP address. So in flat networks, communication is really easy and direct. There aren't overlapping IP addresses, overlay networks, or NAT. None of those things are required. So a flat network is an option if you can afford to assign a unique IP address to each pod. However, if you don't have the luxury of a large IP address space, an island network is a good choice. In island networks, pods don't have unique IP addresses across clusters. This doesn't cause problems, however, because pods in one cluster never directly communicate with pods in another cluster. Instead, as the diagram shows, gateways mediate or translate between pods in different clusters. Similarly, ingress traffic from a client that's coming into a cluster and egress traffic leaving a cluster are handled by these gateways. And gateways perform IP address translations which have the effect of keeping pod IPs private. And these gateways can be implemented in various ways. Some examples of gateways are NAT, virtual IP addresses, and proxies. In an island network, the same pod IP addresses can be used in different clusters. They don't have to be unique across clusters. So you're able to use the same pod IP addresses in each cluster because a pod in one cluster never communicates directly to a pod in another cluster. A major advantage of island networks is that pod IP addresses can be reused in this way. Let's briefly talk about some of the advantages and disadvantages of the two models. First of all, flat networks are faster than island networks because gateways in island networks perform multiple address translations, and these translations incur a performance cost. Another advantage of flat networks is that debugging them is easier. This is because everything in a flat network has a unique IP address, and so it's easier to pinpoint where a problem occurs. For instance, pod IPs aren't masked behind a node's IP address, and so it's easier to determine which pod is causing problems. Similarly, client IPs aren't obscured in flat mode the way they are in island mode, and so that also helps with debugging. However, you may not be able to implement a flat network if you have scarce IP addresses or if your IP space is fragmented. And by fragmented, I mean you don't have large chunks of IP addresses. So in that case, an island network may be a better option. Of course, the flat and island network models, those are just two of the possible network models, and there are lots of variations even within these models. So in this video, we looked at two commonly used network models, the flat mode network model and the island mode network model. And I briefly pointed out some of their advantages and disadvantages. Thanks for watching Learn Kubernetes with Google.